The standards are the key to BIM and GIS integration. We need a common language to talk, to connect, and collaborate. So in this September, Hong Kong Construction Industry Council, CIC, released its BIM Standards Phase 1. So how users could use the CIC BIM Standards on a project, and what are the requirements for stakeholders during the design and construction stage? So today we are pleased to have engineer Ronan Collins. He's an experienced BIM manager and a professional member of Hong Kong IBIM. So may I now invite Mr. Collins, your time.
Thank you very much. Josan. So I have a challenge. I have to do a 30-minute presentation in 20 minutes, so we don't take any time away from your coffee break. So I'll be as quick as I can. First admission, I'm an engineer. So I studied civil engineering. I know a lot about concrete, I know quite a lot about steel, and I know a lot about coordination of design. But I know nothing about data. So when we talk about geomatics, and we talk about BIM, and we talk about GIS, my weakness is I don't understand what data we're going to be sharing with you, the surveyors, and how we interact with the data. So when it comes to BIM and collaboration, I will be the first to admit I need to learn a lot more about data and exchanging of data. So where I come from, cavemen wielding iPads, right? So the construction industry is a very traditional industry. We have a lot of brilliant people with a lot of experience, and they like doing things a certain way. And they don't like to be told to start using 3D models or start using VR or use iPads. They like to do it the traditional way. So to change the construction industry and bring innovation to our industry, it's a slow process, it's often very difficult, and we don't get the opportunity to share ideas all that often. So before I start my slides, I quickly want to show you a video that I found during my research. This is a 3D model of Berlin that has been developed from photogrammetry. These buildings are all accurately measured in size. But the best part about this is not the level of information, the level of detail. This is publicly available information. You can take this model, you can download it on your computer, you can measure the distance between buildings, you can add in buildings. Okay, so the key message here is that for Hong Kong, we need something similar. We need to create open, shared information, get it in the public domain. I've lived in Hong Kong for 15 years, and I love Hong Kong. We have to beat Singapore. We have to get there before Singapore. So Singapore have got a plan for a digital city, and this is an image of their digital city. This is a call to action, Hong Kong. We have to step up. We have to get there before the Singaporeans. So my motivation in my speech this morning is to get you to understand that we have all the tools available, and some of the speakers you'll see this morning, they've been going around surveying Hong Kong. Now we have the chance to get ahead of Singapore and show them we're actually better than Singapore. So there's a few gentlemen in the front row nodding their heads, but I'm all for beating Singapore. So what is BIM and what is the CIC's approach? We talk about a conservative industry in the construction industry, and we have the Construction Industry Council, who are very proactive. Miss Ada Fung is probably the champion of BIM in Hong Kong, and she has got a lot of enthusiasm, a lot of energy, and she is pushing the local industry council to promote BIM. So we have two tactics. One is to push. So my speech this morning is one of those pushes to get more people to use BIM. And we also have a pull. We want to train people how to do it. So we have to actually encourage architects and engineers to do the work. So we have a roadmap for BIM from the Construction Industry Council, and it's basically some guidance on how we're going to get BIM being used on more projects. So it shows what's been happening in Hong Kong, it shows what's happening overseas, but it comes up with some recommendations for Hong Kong. And it's not a bunch of BIM gurus that are developing these strategies. These are being developed by all the Hong Kong government agencies across all the different departments, involving all the major developers, the Airport Authority, the Metro, MTR, and many, many other large organisations. And all the professional bodies are also involved. So the whole industry is supporting the initiative. There are 17 recommendations in the CIC BIM roadmap, and I'm going to speak to you about two of them this morning, particularly the one which is the standards. But you can see here we need to improve collaboration, we need to improve incentives. Legal insurance is a big challenge. So how do we actually make sure that we move away from traditional 2D contract documents into reasonably robust 3D information sets that are reliable? Because at the moment, all of the Hong Kong case law is based on 2D drawings. So when it comes to being, is the BIM model contractual? The answer is no. We have no contract law based on BIM. We have to do more promotion, which I love doing, which is why I'm here this morning. And we also have to keep in mind that Hong Kong is Asia's world city, but we work in a global marketplace. So we keep seeing people from the UK coming and presenting their ideas. We keep hearing of companies coming from America trying to sell their ideas. How often have we gone to America and tried to sell them what we do in Hong Kong? Okay? So we have to start thinking about, we have some very clever engineers, we've got some very brilliant surveyors in Hong Kong. Why aren't we going out and competing in the global marketplace? We don't have to just work in Hong Kong. So the CIC, to help with this, they're building an Innovation and Development Centre in Kowloon Bay. So the CIC BIM Training Centre will open, I believe it's opening in the next couple of days, but it's certainly opening around this time of the year. It is equipped with all of the latest and greatest technologies. So Joyce is going to show you some examples of some laser scanning and LiDAR. They've got all those toys in the Innovation Centre, so you can go and play with them. It's designed to support small companies, so whether you're a major government department or a small company, you can learn something. And it is going to be a library of lots and lots of examples of different projects, different files. So if you get a chance, it's definitely well worth checking it out. The CIC standards for BIM have been developed, as we say in one of the sayings, you stand on the shoulders of giants. We took the information from the Housing Department, from the MTR, from the Hong Kong Institute for BIM, and many, many other organizations in Hong Kong as a starting point for the CIC BIM standards. So these are very much a local set of standards for the local industry based on local practice. We also looked at the UK standards, the Singapore standards, US standards, and we came up with the CIC BIM standards. So the CIC BIM standard is based on best local practice, but is also based on best international practice. And what's interesting is there are essentially 3 or 4 software companies that are driving the construction industry BIM development, and those are global companies. So as a result, the standards are global. So whatever works in the US is going to work in Hong Kong, whatever works in the UK is going to work in Hong Kong. And what was interesting doing this study, I spent time in Beijing. I was talking to the standards development officers in Beijing. They're also following what's happening in the UK and what's happening in the US. So the mainland Chinese, the Hong Kong standards, and all the international standards are very, very similar. So we don't have a special Hong Kong version. We have a version that works locally, but based on international best practice. So I want to get 3 ideas across this morning. The first one is, we have to make sure that the government departments, the large clients, the major developers, are the people who are actually driving the BIM agenda. They have to specify what they want, they have to be able to write that down in clear, concise language, and they have to then make sure it's delivered. If a client is not in charge, they're not going to get information they can use. They're not going to get data that's structured properly, and the information will end up in the bin. So one of the biggest challenges when we talk about geospatial information and BIM information is if it's not specified correctly by the ultimate owner, it's never going to be useful when it comes to sharing with other departments. So it's very, very important that clients involved. So when we talk about client involvement, they have to define the scope of work for the BIM process. They have to define the responsibilities of the participants. What's the architect doing? What's the engineer doing? What's the surveyor going to produce? How are they going to share the information? When are they going to share the information? What formats are they going to use? So it's very, very important that client is seen to be the owner and the manager of that process. And the reason that that is so is basically this diagram is a very simple illustration of our industry. We work in silos. How many people here work in the design sector? Not that brave. How many people work in the construction sector? Who's working for contractors, subcontractors? More people, okay. So how many of you work for government departments or clients or developers? What are the rest of you doing? We see the industry in 3 silos. We have the client who's got the money, and they're the guys that never pay us enough. We have the architects and the engineers that design the buildings, and they do the least amount of design they can get away with. And then we give it to the construction sector to build the buildings, and they always take too long and it always costs too much money. But at the end of the construction process, all of the digital information is then handed back to the client. So at the beginning of the process, if the client is not clear about what data they want, what format they want, by the time it's gone through the hands of the architects, the engineers and the surveyors, and by the time it's gone through the hands of the contractors, the subcontractors, etc., and is given back to the owner, it's of no use. So this is why the real important role of the client is to understand what they're specifying and what they're going to get back at the end of the process. As part of the CIC BIM standards, we've identified 19 different possible uses for BIM. So the first thing the owner has to do is, which of these 19 different uses is applicable to my project? And this is like a menu at a very expensive restaurant. The more dishes you pick, the more expensive the meal is going to become. So if you pick all 19, you're going to have a very, very nice meal. You're going to enjoy the experience, but it's going to cost you a lot of money. Okay, so one of the things you have to start recognizing is, how do I manage my expenditure on these projects? Before I go through the 19 examples, what I want to do is also put to bed one common problem in Hong Kong. We have architects, we have engineers, and we have QSs. We have site surveyors, we've got land surveyors. 95% of them are still working in 2D land. Okay, so most architects, most engineers, and most surveyors, they're still using 2D tools, whether they're 2D CAD tools or some other form of 2D tools. The industry is still working in 2D land. For us to move into the world of shared BIM and shared data and everything else, we have to get the architects, the engineers, and the surveyors to start using these complicated Revit tools, or ArchiCAD, or Tekla, or other tools. So the general industry practice in Hong Kong over the last 5 to 10 years has been for the architect to produce a model, or have a contractual requirement to produce a model, but then give it to an external BIM consultant. And the external BIM consultant will take 2D drawings from the architect, produce in CAD, convert them in a 3D model, and then give the 3D model to the owner and going, there's your BIM. It doesn't work, because the architects are not using the tools, the engineers are not using the tools, and nobody's learning the process. Best international practice, and Hong Kong wants to be the best, we have to get the engineers, the architects, the surveyors trained and experienced in using tools like Revit, ArchiCAD, Tekla to actually design in a 3D environment and then produce documents from that environment. So we have to turn the construction industry in Hong Kong around slowly. So part of the CIC BIM Standards is to make sure that we get the architects, the engineers to work in the right tools, and then we can start talking about shared data, shared information. So we talk about design authoring. It's basically using a building information platform to actually produce properties, quantities, schedules, drawings from the models. The tools can also be used to quantify the models. So we can quantify numbers of doors, numbers of units, etc., etc. And this applies not just to buildings, it also applies to infrastructure. So I know a lot of you work in non-building environments, but this BIM works across everything. So let me show you a basic example. This is a Revit project. This is a multi-use project. It's actually in the Middle East. So you can see here that the model generates a drawing. So that drawing is generated by the model, not the other way around. Okay, so the first lesson in life is we can actually produce pretty good quality drawings. This is not 2D CAD, this is actually a Revit deliverable from the technology. We can do the same thing with sections, so you can see the quality of sections. And then I'll do the same with elevations. And this is the crossover. So this is basically an area chart. The biggest crossover that I personally can see in the near term is taking design information about the space inside buildings and sharing that information in a more GIS environment. So understanding what is the floor space in each floor, where are the apartments, where are the entrances to those apartments, where are the fire staircases, where are the lifts, and having that information available to planners, to emergency services, to medical services people. But the information we need from BIM is not what color is the tile, it's not what type of door is it. We simply want to know what space is in the building. The space is what's useful in a geospatial environment, not the type of wall, not the type of door, not the type of handrail. Okay, so, but this is not typically what architects work to. They don't think about modeling space, they talk about drawing things. So when it comes to design review, this is option number 2 in the BIM world. This is a very simple example of a slope formation. This is a rock slope which has been formed for a project. And the model is being used to look at all the different scenarios. So it's looking at where are the different cuts, where's the different drainage runs, what areas are being excavated to what level. And this is part of a design review process. This is the most common use of 3D models, looking at what are we designing and how are we designing it. What's interesting in this model is that the green is actually GIS information. So it's actually being given to us from the lands department. So it's basically a traditional survey of the slope. And then the orange is information that we've generated in a BIM process. So we've actually worked out levels, elevations, cuts, using a Civil 3D process to work out how we're going to form the site. So that this is a good example of where the two worlds meet, but they're only meeting in the sense of 3D surfaces. They're not meeting in any sense of data. So it's really looking at what data is there in that environment that we can use. You're going to see some very good examples coming up of laser scanning. And this is a process of taking 3D information from basically a survey and generating 3D models in a BIM environment. So this is an example that we were involved in a historic building. So you've actually surveyed the building using the latest modern survey equipment, and then you use that data to build a model. Again, another example of GIS crossing with the BIM. This is a housing department example. So we were given the GIS environment for the entire area of the city, and then housing department started to study the different arrangement of blocks in that building. Some people call it clash detection, some people call it coordination, but to be honest, finding pipes clashing against steelwork is actually really simple. The software does it automatically. The problem is not finding these clashes, the problem is getting them fixed. And the challenge in running a BIM project is understanding when do we start modeling all these different systems. Because clearly from this example, all the drainage pipes are hitting all the structure. So the two teams were working completely in isolation. If it was a BIM process the team had more experience, they wouldn't have modeled the pipes hitting the seawork, they would set them up in different places. So a lot of learning, once you get the industry to start using the 3D tools, we won't see these kind of silly mistakes because the piping engineers will actually model them correctly. They won't model them and then find the problem. So again, the sooner we can get people in the environment, the better. Cost takeoffs are quantity takeoffs. If you work as a quantity surveyor, you spend your entire life measuring off drawings and then running calculations to figure out what something costs. The measurement of the drawings can be fully automated through the BIM process, saving 30 to 40% of the hours in a traditional quantity takeoff. So by using the models correctly, we can actually become far more efficient at determining the cost of a project, and we can focus on finding ways to make the projects more cost effective. 4D modeling, so if you're working in a BIM environment, you can tag in time. In the land of 4D and BIM, we're linking the construction scheduling to the BIM information. And what we're doing now is we're linking the 5D information to the 4D information so we can get cash flows on projects. So you can actually look at how you're spending money and how you're developing the project. But that doesn't really help when it comes to GIS. One of the other exciting opportunities in our industry is 3D printing. How many people here own a 3D printer? Oh, we got one. Can we come round to your house? How many people here want to own a 3D printer? My wife won't let me buy one. Well, we now have a kid, so I'm waiting till my kid is old enough and I'm going to buy my kid a 3D printer. We're not going to use Lego, we're just going to 3D print whatever we want. But 3D printing is changing the way we plan and come up with construction projects. This is an example from one of Hong Kong's biggest contractors. They've 3D printed a pipe formation, or a pipe stack, to make sure they can actually do all the maintenance of the valves and get access to all the valves. So 3D printing has gone from being something that's a fanciful idea to something that's got huge practical applications in our industry. And then this is probably the biggest link that can be used between the BIM world and the surveying world. We now have the technology that if you've built the model correctly to true world coordinates, we can take all the survey points directly from the model, put them in the survey tools, and set up the site. So there's a large number of companies, Trimble is probably the best example, where they're actually using links from the actual models to set out buildings. Now, I'm an engineer, I came from the design world. This terrifies me, because what it means is that a graduate engineer working for a design consultant, if they don't set the model out correctly, and then the model is relied on site, you can imagine how many problems we're going to have on the construction site. And this leads to a very, very important point around the whole idea of GIS and BIM. If the data is wrong, if the model is wrong, whatever we think we're going to save is going to cost 10 times that on site. And the biggest challenge that the professor has, I don't know where he's sitting, he's left, is he? The biggest challenge the professor has in this school is getting people to understand the need for accurate, proper, and precise modeling. And what we're finding is we're having to rebuild models. So models that were built by designers have to be rebuilt by the contractors because they need to be more accurate. So these tools that we're talking about sites setting out from, we need to make sure that they're actually correct, and it's a big, big challenge. And then another thing we're looking at, taking the world of laser scanning and using it during the construction process. So laser scanning started off measuring existing facilities, measuring existing buildings, surveying existing buildings. We're now using them throughout the phase of a construction project. So we're actually installing steelwork and then surveying the steelwork before we start installing the cladding system to make sure they're lining up. Or we're installing piping systems and then going in and surveying the piping systems before we install the ductwork systems. So I've talked about the clients, I've talked about the consultants. The last key message, and I'm running out of time very quickly because I'm already 5 minutes late, is to use the project execution plan to make sure the information is shared between the architects and the contractors. One of the challenges in our industry is the silos. The architects do not want to give digital information to the contractors. The engineers don't want to give digital information to the contractors. They're much happier issuing a PDF, and the PDF is a drawing sheet, and it says in the bottom of the drawing sheet, do not scale, use dimensions only. Or my favorite, when you look at a drawing and there's an area that hasn't got any detail, and there's a little block that says, details not shown for clarity. I'm like, well, if it's not shown, how can it be clear? Okay, but the culture of our industry is because the documents are contractual, they're done in a certain way that if they're issued as a PDF or if they're even issued as a hard copy, I'm out of danger. The engineer is going to have to do his own drawings. When we start working in the world of BIM, we have to learn how to share the information. And there's a big, big challenge getting architects and engineers to build accurate information and then have them trust the contractor to use the information correctly. So again, in my lifetime, we have to get over the culture of our industry, which is, I don't trust you. That's our culture. I don't trust you. I'm going to skip LOD, except I've got one observation on LOD. There's an LOD for the city GML, which goes 1, 2, 3, 4, 5. And there's an LOD for BIM, which goes 100 through 500. And they are completely different, right? So one of the challenges that we have with the city GML and IFC is that we're talking different languages. And we're having the same problem in this domain where one organization is talking about one set of LODs and another organization is talking about a different set of LODs, and they don't line up. And it confuses people. It's not that they don't understand, they just confuses people. Before you go to your coffee, my call to action of a Saturday morning is please spend some time and learn about BIM, learn about the challenges of BIM. Come to these seminars either arranged by CIC or the RICS or whoever's organising them. But most importantly, start talking to your colleagues about how can we share information and how do we structure information so that it's actually useful. And I don't have the answer as to how BIM works with GIS. I don't know anything about data. So in my business, we're going to keep figuring out how pipes keep hitting against beams. And sooner or later, Carsten or one of his guys is going to say, we need this information so we can start doing this with the city. But for now, in my experience, BIM will stay in the buildings and in the airports and in the railways. And very little information will leak back out to the geospatial environment. And maybe over time that will change, but for now, we're still working in different silos. But I will leave you with one idea. BIM is here to stay, and we do live in a 3D world, so you better get used to it. Thank you all very much.